Most of you are probably aware that on freeCodeCamp.org we have a comprehensive and interactive curriculum to help you learn full-stack web development. Well, we're constantly adding new certifications, and our new Web3 curriculum is ready for you to try. It's still in development, but we now have 5 integrated projects ready for you to complete. In this video, you will watch freeCodeCamp team members Shaun and Tom complete the projects. So get ready to learn more about Web3 and see if you can follow along with Shaun and Tom as they work through the projects.
Welcome, freeCodeCamp. This is the Web3 curriculum. Tom and I are running through the integrated projects that we have ready. And in front of us, we have the article that shows you how to run the freeCodeCamp Web3 curriculum in your local VS Code setup. It walks you through what projects are available, as well as how you can run the course. Once more projects are ready, you will be able to sign up for updates and just listen to your emails, because once we start releasing, you'll get updates on those. So to get started, we can head to our terminal, and we just need to git clone the repo, which is in GitHub at freeCodeCamp Web3 curriculum.
Yeah, it mentions in the instructions there kind of specifically what to do, I think. So there's a few prerequisites, obviously VS Code, and then Docker is the main one, I guess, because this all runs in Docker. So you have to install those 2 things for sure. And then once you get those few prerequisites installed in the article, then you can, I guess, just clone the repo and run it or something like that. We'll share a link to the instructions to get it set up in the description there. So,
and once we make sure that we have Docker running, we can inside VS Code open up the command palette and say remote containers rebuild and reopen in container. Now this usually does take a while, but what I like to do is either go make myself something to drink or just watch the terminal as it builds. Okay, is that it ready?
Yeah, I think this is what I typically see when it's ready, is that the last thing installs that last extension there.
Okay, awesome. So now we can use the freeCodeCamp extension to run the course. First, we'll prep the course. And you can see what it's doing if you head into the terminal labeled freeCodeCamp run course. But you really don't need to worry about what's in there. So let us begin. You are introduced with the landing page, which describes the course. There will be a link to frequently asked questions, just in case you get stuck or are confused with how to start. As you can see, there are quite a few projects that we have coming soon here. Currently, the projects that are ready are what we are calling the integrated projects. The integrated projects are like certification projects on the freeCodeCamp/learn platform, in that you don't learn anything through the course. You are prepared through practice projects. You get taught the content that you need in order to complete the integrated project. So the integrated project just has a bunch of user stories that you are expected to complete in order to go through this.
All right, I got this loaded up, and what I'm going to try and do is go through this first available project. It's called Build a Video Game Marketplace Blockchain. So you click on it and you come to the instructions here, and then it gives you the files there. Okay, so I guess we're going to create a blockchain for Video Game Marketplace. where we can buy and sell items, and we're going to work within this folder. So I'm going to just go in there to start. Okay, it says JSON files will store information about your blockchain. There are functions in blockchain helpers for reading and writing to them. You'll need to look at those to see what arguments they need and what they do. They're already included in the files where you need them. The items you can buy or sell are in items.json. So we've got this items.json. I can buy some stuff there. Many of the files are finished for you. You only need to add code in this handful of files and run terminal commands and finish all the user stories and pass the tests. Okay, so your blockchain will be stored in blockchain.json. You can initialize by running node init blockchain. Okay, there's just a bunch of user stories here that'll explain to you what to do. Node generate wallets, so we can create some wallets. Yeah, mining blocks, hashes. Oh, geez, there's a lot of stuff here. So this blockchain.json is going to hold our blockchain, and then we already looked at items. Transactions is going to hold transactions, and wallets is going to hold wallets. And then there's kind of examples here of what they're going to end up looking like. Blockchain has some things there, and etc. Okay. Let's just see if we can't pass one of these tests or something. Oh, look at that. That looks good. Actually, whatever, I'll just leave it. First one, let's see. You can initialize running node init blockchain should replace everything in blockchain.json with an array that has one object, the genesis block. It should have a hash property of 0. Okay, I think this one's not too difficult. So we've got two helper functions here, write blockchain, write transactions. Should replace everything in blockchain. Write blockchain. Genesis block equals to.
So obviously the Genesis block is the first block in the blockchain, which you often have to hard code because you'll find it doesn't have a previous hash, so you can't really generate a hash for it.
Yeah, so I have a hash of 0 and a previous hash of null. And then the blockchain, we're going to save that, but blockchain should look like this. And I think running that should do that. Okay. We could run it and see what it looks like. Let me see, what does my blockchain look like? Node init blockchain, there it is. And let's see, there must be a test that goes along with it. Running. All right, we got the first one to pass. Should replace everything. So same thing, replace transactions.json with an empty array. Currently it's empty, but if I go here, write transactions. So write transactions, just like that. Yeah, these helper functions, they just kind of write to the file, I guess, and get things from the files, the JSON
And
files.
if we wanted to see what those helper functions looked like, just in case maybe the name doesn't describe them fully, where do we see that?
This is all in this blockchain helpers file. There's a bunch of them. Get and write blockchain. It's pretty much just Well, there's quite a few here, I guess. Getting balances and stuff. But yeah, you should say here, do not change code in this file, so you don't need to change anything. It may mention some things about some of them elsewhere, maybe in the instructions. Okay, what do we got next? Running node generate wallet with the username should add a user as a key in wallets.json with a public key and a private key properties. The value should be a public and private key pair in hex format. Uses the font. So let's see what this one looks like. We have no wallets and generate wallet. Okay, so we're gonna get a command argument from the command line. New wallet name. So public and private. I know there's instructions on how to do this. Generate a key pair. Okay. So just go const key pair equals ec.gen key pair. EC is already here for us. And then get some information from the keys. There's a user story on this one.
Need to watch out for those typos, eh?
Did I have a typo? Thank you. Should be able to create a wallet. Well, let's see what the examples look like. Here we go. Wallet name, public, private. There we go. That helps. Okay, so public equals get hex public key from key pair. Okay, I think that's right. Const private equals pair dot get private hex, and then get wallets. So we don't want to completely replace the wallets we want to add to it. So I think const wallets equals get wallets. So I guess we can probably just skip some validation and do wallets dot new wallet name.
So what validation would you do?
I would make sure there's not a name already in the wallet.
Right.
This is the only thing here. And typically wallets aren't stored like this. This is just for this project. So you can see it and have access to all the public and private keys. Okay, so wallets and in wallet name. So we've got public key and private key. Public key equals public. Wallets dot new wallet name dot private key equals private. Are those keywords? Public and private? Is that why I'm getting underlines? Private is a reserve word. So
Yeah, it
public.
seems TypeScript is messing with you.
Okay, and then we should just do write wallets. And then if I save that, open my wallets names, node. So this is all in the instructions, but I have it somewhat memorized. But yeah, you can create a wallet with this. It says, so we're going to try that. Generate wallet. Me. There's not set
Yeah,
properties.
I was wondering if you needed to make that dynamic.
Oh, yeah. Okay, so equals, let's set new wallet name, public key. If I just do this, this work? Public key equals pub. No. I'm not used to this keyboard.
I think just remember, new wallet name is not the name of the key you want.
Oh, was that my problem?
Yeah.
Obviously. Thank you. That should work, I think. No, more errors. Data argument must be a string or buffer. Now what? Invalid argument type.
Well, when you're writing wallets, you don't seem to be doing anything with the wallet you just created.
Oh gosh. Okay, wallets equal get wallets. Wallets, new wallets name. Wallets, wait, wallets. Okay, wallets. Thank you. You gotta look. Maybe I should have put more information there. Okay, I think it worked. It worked. Ha!
Awesome. I think the fun thing about these projects is you get to, try out what you're making as many times as you want.
Yeah, you're cutting out a little, but yeah, I got you. Okay, so we got one more thing done, hopefully. Running the wallets, creating wallet works, and it has key pairs. When you generate a wallet, it should add a transaction at the end of the transactions array. It should have a buyer address, property of null, and buyer address, property of null, and seller address. That is the public key of the new wallet. Okay, so let's look at this add transaction, I assume. We'll go back to generate wallet. Get transactions, write transactions. Okay, so we'll just, we wrote that. Const transactions. Let's get transactions. And then I guess const new transaction equals something. And then transactions dot push transaction transactions dot write transactions dot write transactions write transactions. And then this transaction, I should add a transaction at the end of the transactions or the transaction buyer address of null. Okay. And seller, it's public key of the new wallet, a price of 40. So public key, we'll just go like that. Price 40. I suppose I don't know. But let's see what happens there. Okay, that didn't work either. Now the old one's broken. New transaction equals that transactions push.
You need to watch out for what you actually name some of your variables.
Why don't you just tell me what the answer is? You see something, don't you? Seller address, pub. There. Is that what you were looking at?
Yeah.
Aha. Okay, so now when I look at my wallets, we got 2 wallets, and transactions, we've got nothing in there. So I'm gonna just go like that once. Wallets. I don't have a trackpad. Where's my trackpad? Wallets. Okay, let's look. Third wallet, test. Okay, we got a test wallet, added that, and now we have a transaction. All
Nice.
right. Running node mine block should add an object to the end of the blockchain.json array with the correct hash, previous hash, nonce, and transaction properties. Oh boy. So this one sounds a little trickier. After you run, it should be an empty array. So I guess we're gonna need a const new block type thing. Nonce hash previous hash transactions. Maybe something like that. We'll see. Equals. So we've got helper functions. Let's use those. Get blockchain. Last block blockchain. So you want to get the last block so we can get the previous hash. So the blockchain is going to have this, and we're going to want to get this hash so we can put it on the next block, and it'll be the previous hash value of the next block. So last block equal blockchain dot length. Oh, -1. Blockchain dot length. That sounds right. Just comment this out once. Console.log last block. Let's make sure that's working. There it is. Okay, so it's working.
Nice, yeah. I wonder if you don't need to worry about mutating blockchain. You could just pop it off the end.
I mean, in this, no, you probably don't want to do that, right? You would need to put it back when you go back to write the blockchain.
Yes,
Because
that's true.
you can't remove a block. Okay, previous hash equal last block dot hash. So we got one thing down, I think. Nonce. I think we're gonna have to look at the rest of the things for that nonce. Okay, so hash and nonce, those are gonna be tricky transactions. Let's, after you run, it should be an empty array. Okay, we can add that one quick. Const. Actually, we should just be able to go to write transactions like that. I think. So, assuming everything gets mined correctly, we can make that an empty array. I want to go up to these user sources. I think there's some information. Generate a wallet. Okay, so it looks like we kind of got a large portion of the top done. Okay, the hash should be creating using SHA-56. Okay, concatenating the nonce, the previous the hash of the previous block. Okay, so yes, we need to do some sort of loop here. I guess let hash equals this while, and then I know there's something in here about it having to start with some zeros. There we go. The hash, and yeah, let nonce equals, just start with 0. So while hash not dot starts with 0, 0. Create new hash. Hash equals SHA-256. And then I think how to work with keys, SHA-256 hash. Right there, there it is. Can I copy that? There we go. Okay, content to hash. It says up here, the hash. Okay, concatenating the nonce plus previous block, last block dot hash plus the stringified version of whatever is in transactions.json. Oh, geez, look at this. They copied. I could have just copied this whole thing. Just need to read. Transactions. There's some dots there. I don't have transactions. Oh, I think I do. No, I don't. Get transactions. Okay, so. And then we want to probably do nonce plus plus. We'll start. Okay, yeah. So it's gonna keep going until it starts with 2 zeros. Nonce will be 1, 2, 3, 4, 5. Okay, the previous hash should be the hash of the last block. Let's change that. Okay, that looks right.
Yeah, do you have everything for your new block now?
Nonce hash transactions. Is that just a JSON? I think so, yeah. Yeah, that looks right. Let's see if it works. So the transactions is supposed to go empty, and we're supposed to get a new block, I guess. Node mine block. We did not get a new block because I did not write it, but I did delete the transactions. New block equals this. Blockchain equal get blockchain. Blockchain dot push new block. And write blockchain. There we go. Now we don't have any transactions, but you know what? I'm just going to generate another wallet quick. Test 2. Now we have a transaction. And yet another wallet. Okay, let's see if that worked. Node mine block. All right, no more transactions, and we have a block. 351
Nice.
tries. And then I guess I can come run these tests and see what is passing for me. Running node line blocks and hash, previous hash, nonce. Did I do something wrong? What have we got here? Previous hash 0. That looks correct. Hash, that looks correct. Nonce looks correct. Oh boy, something is missing. Hash, previous hash. nonce transactions.
I'm wondering now, if you go back to your little algorithm for calculating the hash, because I remember coming across this a lot while doing learning about the cryptography of blockchains, looking at the nonce that you're calculating the hash with, and then the final nonce that you're ending up with.
Oh, geez. Let's just do that. We'll just do it first. It's probably what's the right way to do it? Tell me the right way to do it. Okay, let's see what happened.
I'm just gonna get my cat.
Still didn't. Okay. Something isn't working. While not.
We know the internet has an obsession with cats, so this is Archie. Did you pass that test?
No. I wonder what the test is doing. Should add an object.
Well, I mean, the one thing I can think is if the hash, the nonce needs to be 0, you're never actually testing that.
What's that?
So if the nonce is ever 0, you're never calculating the hash based on that, because you're always starting with 1. Kind of a probability thing that's probably not going to happen, but
With the nonce, it just goes until it finds one. If 0,
yeah, but you're never checking 0.
well, that's fine, because if 0 works, it'll just go to 1 and check 1, and then it'll go to 2 or 3, whatever, until it finds one that works. And then you can use that one. I don't know. I know what I can try though. Nonce hash. Wait, did it pass? Running node my blockchain object. And transaction property. Transactions.
Do you need to add a transaction anyway?
I don't know. I feel like that one should have passed.
Well, if you go to the console, is it saying anything?
There you go. Now you're thinking.
I don't think we've even seen the console yet.
Yeah. Okay. Running node bind block. Let's see what it says here. The hash of the new block should be able to be recreated with these things. Expected 006. Maybe you're right. Was it the to equal 0D? So what one? So my hash has 2 zeros. I can't get back very easily. I need my touch trackpad.
So it's expecting only 1 0.
No, it's just saying it's supposed to be able to be recreated. So it should have nonce previous hash addition. Nonce previous hash last block dot hash. That should have been correct. JSON.stringify transactions. I'm gonna
check where you are doing the .to string. Okay, so what's transactions.json? On line 20.
array. Oh, There it is.
Yeah.
Oh, stupid. Transactions, not transactions, not JSON. Did it say that? And I should have copied and pasted. Did not say that in the instructions. It did say that. There's a bug.
Oh no.
Well, kind of a bug. It's a bug. Okay, let's try it again. Let's see if that works. Console. Running node mind block. There it is. We got another one. Thank you for that help. Okay. So, do you mind writing that down? You want to take a note of that? Oh, what are you doing?
Yeah, we'll take a note of that.
Okay. Running node buy item. So we need buy and sell items. Running node buy. So we're gonna run this command buy item with one of our wallet private keys and the item we want to buy, and we need to add a transaction for it with the correct buyer address, seller address, price, item bought, signature. So this is the test text. There must be more information up here. So, but I know we're gonna need const. Let's call it new transaction. What's this? And we're probably gonna need transactions equals get transactions. You know, it's always satisfying when you come across a problem like we just had, and then you start to think that maybe you have an issue with your tests, and then find out that your test is working. Okay. Transaction. When you buy an item, yada, yada, yada. So the buyer address should be the matching public key for the private key entered. So it looks like we're going to get a private key, and we need to find public key from that. So const pub is a keyword in Rust, isn't it?
Yeah, it is.
So I have some poor variable name choices, maybe. So get key pair from private. Pub equal private key. Public keys. So we should have key from private, get key pair from private. So that'll get us a key pair. So that'll actually be key pair. And then we need, I think, we need to get hex public key from key pair. That should work right here. So const pub. I'm gonna make it a little better. I think it's a little better. And I'm just gonna console log key. That shouldn't do anything. Save that. So I should be able to run node buy item and enter a private key. So if I grab this private key and run it, oh, come on. Why can't I paste? Copy, paste. I should get a log with the public key. That is the public key that matches, that works. Okay. So we have the public key. Okay, we need to run that. So, okay. Buyer address public key. Seller address null. Price should be the purchase price of the item bought. Item bought equals that. So get item price. What does that do? Get item price, items. So it looks like it returns the price. I think you could just do get right here, right in the object. Get item price, item bought. Price signature should use the buyer's key pair to sign. Oh, geez. Signature equals buyer's key pair. Key pair dot sign. Here we go. What kind of content do we need? Buy, concatenation, buyer address, price, and item bought.
And these helper functions are really just making a lot better, aren't they?
Yeah. Yeah. I lost it. Price, item bought. Okay. Price plus item bought. Okay, so we should have a signature. And we need to add it probably down here. We don't want that. Why would I do that? Thank God for linting. It'd be terrible. Okay, so supposed to add an object to the transactions dot push new transaction, right? Transactions. Save it, and we will. I'm going to open up this transactions and see if I can do this again. Node by item, and we'll try an icon. But I wanted to see this. Node by item. No. Something's out of order. Buyer address equals public key, buyer address. So I should be able to just do a public key there. I think. Price is not defined. Get item price. Price. Okay. Yeah. Get item price, item bought. Yeah, that wasn't very smart there, was it? Let's try it again.
Yeah, I think I spent 10 or 15 minutes yesterday on a bug that was caused by a trailing comma in JSON.
Yeah.
So at least your error messages are telling you, exactly what's wrong. Mine was telling me unexpected token.
Yeah. Well, didn't it give you like a red line around it? It's just really small and you couldn't find it? You didn't get a red line around it?
No, I think I was editing in Nano, so
oh yeah,
no linting, no anything.
Okay, so I think this one should be working. We bought an item and it was there. So mine block node by item. Buyer, seller, signatures. Well, let's see what happened with this transaction. Buyer, seller, price, signature. Buyer, seller, price, item. We're missing an item.
I wonder what the console would have told you.
We'll check it out here in a second.
Yeah. I'm always interested if it's assertions are specific enough.
7. Buying an item. This one might be a little. I really need my trackpad for this. Oh, I have to scroll down here. I guess that's not bad. I just gotta scroll down a little further. Expected 2 to equal 3. That's not all that helpful.
Are you asserting the length of the object's properties?
Yeah, I guess probably, huh?
Yeah.
And then somewhere in there, I suppose I check the rest of it. Yeah, that's not, or maybe I'm sure I check something. Anyway, I think it'll work now. And since I'm just buy item still failing, let me see if I buy an item again. What now? What icons? We got item. Buyer
I don't think
address,
it's
seller
open for
address,
item.
item bought.
Yeah.
To read my own stuff. Still nothing. Item bought, signature. Let's run it one more time. Buyer address, seller. What?
I notice your transactions aren't clearing. Oh, you're not running mind block, that's why.
Yeah. Seller address. I don't see any typos. Signature? Let's see if that console changed because it's adding an item. It's going to say the same thing, isn't it? That's not helpful. Buyer address. Buy item. Item price. So the price is correct. Signature. I wonder if that's off. Public key. Buyer address. That's the same thing. That shouldn't matter. Signature. Let's see what that signature is supposed to be. You buy an item. Signature. Sign and concatenation of the buyer address, price, and item bought. In that order in hex format. Got a key pair. Key pair dot sign. I mean, the signature's here, so. Seller address, that's supposed to be null, right? Yeah. Seller address should be null. Price should be the purchase price. 10. I wonder if that's supposed to be a string. No. Let me see this example transactions. Yeah, it all looks correct. Transactions, we're pushing it. Get address balance. Is there a caveat in there that I'm supposed to make sure they have enough funds?
Well, it sounds like it's saying you're still not pushing the correct number of objects.
That is what it's saying, but you know what I think it might be?
Yeah.
something to do with the balance. The test is checking if it's got enough balance or something. So I'm gonna start over. I'm gonna reinitialize my blockchain. And because the account I'm using is this one that I created that doesn't have any funds. And add the funds until those other, it's like I guess a reward transaction for creating a wallet. Node, generate wallet. We'll just put me in there. See, now I'm gonna have transaction with the funds. I created those other wallets before those transactions were in there, so I don't know why why would that have anything to do with it? I don't know. I'm gonna run these tests again, see if it still came back. Yeah, there it is. I'm gonna look at my solution. See if there's anything.
Well, I can't think of anything.
Transactions, price, buyer key pair, key from private. Signature. It looks the same for the most part, or very similar. I'll copy it over. Still nothing. Oh, I didn't save the file. I wonder if I wasn't saving the file. I need to turn on autosave. There, it passed. So now we don't even know if or when. I'm going to undo this and see if it's working. Undo, save, and then run it. No, it's not passing. I wonder what I'm missing on this one. Buyer address, seller address. Key pair. All right, we have to do the sell item thing still, so we'll give it another try over there. I'm just going to use my solution for now because it's passing. I feel like it didn't have anything to do with the balance, but maybe I'll dig into the test later and see if...
I wonder, when you sign it, the concatenation, it matters the order, doesn't it?
Mm-hmm.
Did you have the order correct?
I did. I double checked it. Public key, price, item bought. Buyer address is public key.
Yeah, okay. Wow.
Okay.
Do you have to do the check for the balance in order to pass that one?
It doesn't say anything about it. Should not add a transaction if the address does not have a... Maybe. It's right there. I didn't look at the second one. Yeah, this one. Run the test. Okay, these both fail. Yeah, maybe I'll just try transaction equal that transaction number. So let's try it once.
Yeah.
Get address balance. Cons balance equals get address balance. Public key if balance greater than or equal to price. We'll add the push transaction and write the transactions. We'll try that once and see. Maybe that was it. There it is. Wow.
You want me to take a note of that?
I mean, there might be a reason that's happening. Perhaps. Yeah, sure. Take a note. Yeah, I don't like that, but maybe I'll put that user story first.
Yeah, that's probably what I would do.
Okay, running the sell item. So what else have we got? We've got a sell item. I should have at least 3 wallets in my wallets.json. So that's what I was gonna do here. Me, you, I. 3 wallets. I should be able to pass that one. Um, 3 wallets. Okay, and then at the end here we gotta. Oh, they are valid. Nice. At the end we gotta add a bunch of blocks and transactions. Okay, sell item. Let's try the sell item one. Let's keep moving. Keep me on task, Shaun.
Yeah, well, you're almost there.
I'm almost there. So we need to sell item, address private key and item. So the command will have the private key and an item. And we got to add another transaction with the buyer address. So let me go to my buy item once. I just do a little. This is going to be a bad idea, but I'm going to copy this over here. A new transaction. Transactions. These will get transactions. I'm just all over the map with my code too, just hacking away. Okay, let's move some of these up to the top. Well, I don't think we need a price on this one, but okay, so the buyer address is going to be null this time. Seller address should be public key, I believe. Correct buyer address, seller address, price, and item sold price, item sold. And then I believe we actually don't add a signature to this one because we're selling an item back to the game. Or maybe we do. I don't know. Oh, it does say signature. Yes, so we do need a signature. I don't know what I was talking about. There's something you don't need a signature for, though. I thought. I don't remember. Oh, it was the reward transactions. Okay, so I'm gonna scroll up to the sell item thing here. So we're supposed to add that. Buyer address should be null. Seller address should be the matching public key for the private key entered. So we've got a seller private key that comes in, and we have a key pair there, and then their public key. Okay, so we got the public key. Price should be 5 less than the purchase price of the item. So we have item sold price equals get item price. I should just be able to go -5 there.
Yeah.
Signature should use seller key pair to concatenate seller address, price, and item sold. So public key should still work. Price, item sold. There we go. You shouldn't need anything here. I'm wondering if there's supposed to be something that makes sure they have the item before they can sell it, but I don't see anything written.
Well, you might need to check your actual user stories.
Maybe I only kind of skimmed over them. Seller address. Yeah, I don't see. I'm selling. I'm not. Okay. So we do. If what is it? Get address items. I should be able to address const items equals get address items key. I think. So I'm just gonna console log items here. And nothing should be happening because I'm not writing any files. So what I want to do is get an item to somebody somehow. Transactions, we don't have any items yet. So node buy item. And I want to see if when you buy an item, you should be able to buy an item by running by a private key item. Okay. Private key. Let's do a different item this time. A spray. I think it worked. Transactions. There it is. Okay, so now we have a spray we can sell. Let's just add another one. We have two. And it says that the transaction pool is included. The items are, so they should be included. So if I go node, sell item, that private key, get an error. Get item price, item bought, -5. Yeah, maybe I can't do that. Oh, it's because I didn't put in an item.
No.
Oh, is it? Can I not do that either? What is it? You see something? You need to tell me.
It's not item bought.
Item sold. All right. All right. Although I'm not inputting an item here. Okay, so there we go. We've got my items. Here they are. That worked. Everything worked. So I need to say if not items item sold greater than 0. Or actually, you know what? Let's just do if items sold greater than 1. So if you have at least one, you can then do something. Transactions dot push. Come on. New transaction. Transactions dot write. No.
You keep wanting to do that.
Oh, it's just feels natural. Okay.
Yeah.
There. I think that'll work. Let's see what happens if I sell one of these sprays. Console log my items, but that was before it actually changed. Transactions.
Yeah.
There it is. And I think there's a helper function here. I thought items, gift items. Oh yeah, there's a little, you can run that to gift items. Let's run that once. Gift items. I think it should work. Now it sends an item to every wallet.
A
Free
random
item.
item?
Yep, free item to every wallet. That's kind of
Okay,
neat.
that's a fun airdrop.
I wanted to check the balance or get address info. There we go. Node get address info, and I think if I just do the name, there we go. So we have some info there. Guy has a balance of 20 and a few items. Yeah, there we go. That's kind of nice. And let's see if this selling test passed. Cross our fingers here. No,
No.
big fail. Sell item. Let me node sell item. Actually, I'm just gonna node line block. Should clear out the transactions and then sell item. Okay, so now we just have none. I thought it was working before. I must not have that item. What address is that? Okay, node. I think you can use
You're also saying if it's greater than 1, hey?
node items that items sold if it's greater than or equal to 1.
There we go.
Thank you. There it is. And yet it did not pass, but I guess that was probably the problem. So let's try it again. There it is. It passed. All right.
Yeah, those off by 1 errors.
Well, and now we just need to add a bunch of transactions and stuff like that. So node mine block. Just pop these open. I'm gonna pop these open here so we can see what's going on. Blockchain. So you got a blockchain here. What looks like about 3 blocks. Node item. And we need wallets. So I think if I grab a key, hotkeys don't work. Excuse me. Spray. Does the transaction work? There it is. So this person is buying a spray, 2 sprays. That one didn't work because we don't have enough money. Sure, we'll just mine it. This person, node, buy item, paste. We'll do icon. Should just made 3 transactions. To buy some icons, we'll just mine another block. We'll node gift items, node gift items, block. Yeah, you can see it keeps adding to this array, blockchain and transactions, so it's kind of neat. And I wonder how many more we need. Let's see if I have any passing. I don't think that's enough though.
Just add a bunch of addresses. 2 addresses, minor block.
We're gonna do this. Node sell item. I think I need that. Icon. Pose. Mine block. Generate wallet. This is what you want. This is what you want. Shaun. Now we have our own wallets, 40 coins each. Node mine block. Let's see how far we got. 10 blocks. Node gift items. Mine block.
Does not tell you in the console how close you are.
No. Okay, that's got to be enough. There we go.
Nice. Ooh, one project down.
Okay, let's move on to the next project. Yeah, we finished this one, and the next one is build a fundraising smart contract. So it's going to be kind of similar, and that's got a bunch of JSON files and stuff where you put your blockchain in there. Okay, let's see what it says here. It says I need to create and deploy a smart contract that raises funds for my startup. The goal is to raise 150 tokens before the 7th block is mined. You have some boilerplate code and files. I should not need to change any of the boilerplate code. The fundraising contract folder is the only place I need to write code. So I have this folder, which is going to be my contract. And the rest of this stuff is not stuff I need to change anyway. Okay, the initial state is an object my contract will store. JS files in that folder will be run by the contract. On transaction will run when a transaction is sent to the address of my contract, and the on new block will run when a new block is mined. And then it says that the files or the functions on the contract can only run if the status of the contract is open. So yeah, this is my contract state object, and I presume there's going to be some sort of status open, or maybe that automatically gets added. Oh, okay. The only two helper functions your contract files can use are add transaction and update contract state. They are already added in your contract files. Okay, so we've got an on new block file that will run when new block is added, and this on transaction will run when transaction is sent to the contract address, and then these other files is just showing all the things you can use in any other file you're going to need to add here. I know we're going to need to add a couple, I think. It says there's a number of variables that will be passed to your contract files. Ones available are already defined there, and those two files, yeah, so it says there that we can use those variables. And then here's the command to deploy your contract. It says it will create a contract address and put the contract itself in the smart contracts JSON thing. And then it will get added to the blockchain the next time I mine a block. After it's deployed, you can run the contract files with this command. Yeah. And there's some notes here. It says mining a block creates a reward transaction with a random address from wallets such as. Okay. User stories, bonus, hints. There's a lot of hints. So there's going to be a lot of like, okay. Hints, do this first. I'm going to do this first because it says do this first. There's an example contract for you to okay, do this first. It will help you understand how contracts. There's an example contract for you to play with to see what it can do. Keep your eye on your JSON files and run these commands. So we've got like transactions, smart contracts, and maybe blockchain. We want to, I'm in the wrong folder from before, so I better make sure I switch, build a, run this initialize blockchain. Okay, we got a block, node, deploy contract, example contract, because that's the name of the folder here. And then a private key from the wallets. Private key, let's go with this one. Okay, so we should have a message, I guess. Your contract has been deployed at the address. It will be added to the blockchain when the next block is mined. Cool.
Nice.
So there it is, and it has my like functions from the example contract folder and the state of the contract, I guess. So node block, we'll do that. Now it moved over there to blockchain. Add transaction, a private key from wallets transaction. Okay, so
do you want to explain what's in that functions object?
it's the code from these files, these JavaScript files.
So you're just taking the code as a string and sticking it all on one line.
Yep.
Yeah.
It works. It's
No,
I mean it's pretty similar to how, I mean, maybe not that part of it is, but it's kind of similar to real smart contracts in that the code goes on to the blockchain. And that's, I guess, more the purpose of kind of some of this is to get the concepts across. I don't know. I think it's nice.
Yeah.
What do you know?
I think it definitely helps for debugging.
Yeah. All right. Let's try and do a little more here. Node, add private key from wallets. So the contract is now like a different address, and this person, this wallet created it. So you could still use that wallet to send things to the contract now. Private key from wallets, example contract address, and I'm pretty sure nobody has any coins. Or maybe they do, I don't know. So I have to use 0 for the amount. Send something, hopefully, to the, there you go. So I sent 0 to the contract address, and it says someone set a transaction. It is running its on transaction file. Here's what the transaction looks like. And if you look at the example contract, this one, it has all that information. You get the transaction that came in and just a couple logs.
Okay.
So it ran that file. And then you can also run contract, example contract address, get favorite number. Okay, node, run contract, example contract address should be that. Get favorite. I spell that right?
No, you're missing the U in favorite.
Okay, look at this. You got running this file. The favorite number is 10. And then we can set it.
Is your favorite number actually 10?
No, I don't have a favorite number. Example contract address. No, it's actually 11. That's why we're going to change it to 11. Set favorite number. Yeah, it's 11. I'm kind of missing. Like usually you need a private key, to update the state right to the blockchain. I guess we don't in this one, which is fine. But I ran that, and now it should be 7. There it is. And if you were to look through some of these blockchain files, you'd see all that kind of happening. Like, I guess there's a transaction. Okay, the smart contract transactions, basically transactions go in their own file. Let's see what happens when I mine a block. Yeah, and then everything from both these files gets moved over to the blockchain. Yeah, that's right. You get a random reward when a new block is mined, and so smart contracts kind of have their own area here. But I guess typically on real blockchains, they're just regular transactions. But yeah, what were you gonna say? Nothing? Okay. Let's try and get this going. Fundraising contract. So the initial state should have a status set to open and a description to smart contract. Your contract should have a get description file. So these are the new files we need to make. New file, get description.js and update description. So let's make those two update description and console log. I don't know if I can copy that. Maybe that's a good thing. I'm just mumbling to myself here. What's going on over there, Shaun?
I'm just watching you, seeing how the master does it, creating smart contracts.
Yep. Keep your eyes open for those typos. I'm good at that.
Yeah, I think that's why I'm mostly here.
So get description, console.log. Here's the description of the fund contract, and then description here. Probably contract state dot description. So the contract state will be the object here. Yeah. But we need to actually deploy the contract for any of this to work. I don't think I need any of that. I think we just need this one. Okay, updates the description. Updates the description. So update contract state. I wonder if I should look in here. I wonder if it's explained in here what that function needs.
Remember, you can just go to you can hover over the function definition and then control click or command click?
Not convinced you can in these ones, but maybe. What do you do? Command clicked? There. What do I press?
I'm not sure what it is on Mac, but on mine it's control, and then I click on it, and it takes me to the definition. Although, no, you have dynamic import, so it might not do that.
Yeah.
Yeah.
So update contract state, and why update contract state, address state. There we go. Update contract address, and then a comma. We need a new thing. Something from there. Args. Let's go with 0 for now. I don't think I need.
Well, I think you could just console log it, couldn't you?
Yeah, we'll throw that in there anyway. Shouldn't need any of that. Or that. A contract address. No. It needs the whole state object. So it would be contract state, contract state dot description equals args 0 maybe. I'm gonna go with that, but I don't know. We'll see what it says. Guess make sure we save the file. And then let's attempt to deploy it, I think, maybe. Sure. So I'm going to follow the commands from deploying the example contract. We're going to reinitialize, deploy fundraising contract, and then a private key. Paste. There we have it. So let's just find that to the blockchain. And then we should be able to run these functions. Node run contract. Get description.js. Description, that worked. And then update description. We do new description. That work? Yeah, look at that, arg 0. Working.
Nice.
Well, now let's see if the test passed, I guess, huh? Look at all these we got passed already.
Wow. How many left to do? Not too many.
9, 10. Oh, this one's passed too. This one's passed too. Your fundraising contract should be deployed and mined to the blockchain. All right.
Nice.
Okay. So, running the commands to deploy your contract and sending it the 150 tokens. These are created transactions. So our contract needs to raise 150 tokens before the 7th block is mined. And if it does, we need to create a transaction that sends all the funds donated from the contract to the address of the creator. And then also set the status to closed. And if we do not raise the 150 before 7 blocks, we need to send the transactions back to the people that sent them to us.
Okay. So you have to keep that all in state.
Yeah.
Who sent what?
So, initial state, I guess, maybe donated. So let's go transactions. And then maybe an array. And a raised, maybe like a number. Status description. I think that might be enough. So we definitely need to keep track of all the transactions that come in so we can send them back. And I think that'll work. I don't know if we need to keep track of the raised or not. You could just loop through the transactions, I suppose.
Yeah,
So
that sounds like an optimization thing that you may or may not want to do.
yeah. Okay, so this new transaction comes when our contract gets a donation. So we're going to need to, if we get a transaction, what do we need to do? Put it in the state. Also, add to raised or something. Add the funds to raise. We'll just keep track of it for the heck of it. I don't know. Need it. And then we need to check if we have the 150. Send all funds to contract creator. Something like that, maybe.
Yeah, I'd go with that.
Okay, so contract state. So a transaction comes in. Let me console log transaction. Show that in there. What does a transaction look like when it comes in?
Yeah.
Probably an amount. And the address would be the contract address, and the from address would be whoever sends it.
Yeah.
Transaction. So this is tricky. Update contract state, contract address, new state. The state has a transactions object. So you know what? I'm just gonna go. We have a contract state here, so I'm just gonna go contract state transactions push. Work. No, transaction. Push that transaction that came in state. And then we could also do contract state dot is plus equal transaction dot amount, maybe?
I'm not sure you can plus equals on a property.
You can't. Thanks. Contract state dot raised equals. Wait. Yeah, you can. Can't you? Contract state dot raised plus equals.
You can try it. Yeah.
I don't see why not. Maybe. I don't know. Where am I at here? Okay, so we've got a few things happening. Update contract state, add to raised. And then should I attempt to do this right now, or should I? There are helper functions for running contract, playing contract wallet. Thought there was one for getting just the whole state. I'm gonna do. I'm just gonna do this once. Throw another one in there. Why not? State console.log contracts. We're gonna do that. Let's just see what happens. I should be able to deploy this, and we'll see a transaction. We'll do that.
Yep.
Update the state, and then we'll be able to check it with that other file. Okay, so we'll go back to reinitialize and then redeploy. And find the block. And what we want to do is send a transaction to it. So if I look at transactions, there's one there. I suppose I could send 0 to it. Let's mine another block. So now somebody has 50. This person, public key, that's their public key though. Wallets 0412. So here's their private key. To be able to go add a transaction from this person. This is probably all in the instructions. It's just I kind of have it memorized. Helpers maybe down here. Add transaction, I guess. Okay, we already went through that. So we take the private key and then the to address, which would be the contract address. Very large address. I made sure to make them as big as I could.
Yeah, that always seemed like it when I looked at these.
No, I did the opposite actually, but okay, so we have problems.
Well,
50. This is my transaction though. The transaction came in.
Yeah.
Undefined 15, new state. Well, that is the problem. Contract address, contract state. All right, let's try it again. Initialize, deploy, time block. Let's do that twice so we have a transaction. Node, add transaction. Private key, private key, private key. Here we got this person 0416. Contract address. And 50. I think it worked.
Okay. So what files have changed?
This one right here. Transaction showed up from
Okay.
that person to the contract address. We just sent this to the contract, and it did some things there with signatures. And then the contract ran this file here.
Yeah.
So we got this log of the transaction that came in. And then
So if we say get state now, it should all be updated.
node run contract paste get state.js. Here it is. Smart contract status open transactions. Nice.
Okay, awesome.
So now we need to do like if contract state dot raise greater than or equal to 150. Send all funds to creator, just like I put right there. So we need to add transaction creator address. So I suppose that would be their public key of the creator and private key.
Well, wouldn't you first put all the transactions into the blockchain that the contract has state for, and then send a transaction from the contract to the owner?
Say that again?
So your contract state has a bunch of transactions in it. You need to mine those so that the contract address has those funds. And then you need to, from the contract address, send a transaction to the owner.
Well, I'm just storing the transaction information in the contract state. The actual transactions are also going into the transaction.
Oh, right. They're already going through, right?
Pool, right. So they're already going onto the blockchain.
Okay.
I just need the information so that if my contract does not succeed, I can send all this stuff back. And I probably only need like the from address and the amount from each transaction. That would be enough to send it back. So I'm gonna do that, I think, on transaction. You know what? I'm not gonna do that. All right. So what was I looking at here? This private key. I presume, is that the private key of the contract itself, maybe? It's kind of hacky, but
you can. Yeah, you need to sign it from the contract.
no.
Yeah.
And so I wanted to find this function and see what it looks like. Add transaction somewhere. You know what? There's this thing you can find. Right in here somewhere. Private key to address amount. Add transaction. Private key to address. Creator address amount. Contract state dot raised. That sounds right.
So you're definitely sending everything through, even if it's over the goal.
Yeah. Yeah, isn't that how real fundraisers work? You can raise, you set a goal of something, 10,000, but you can also raise much more. Like
I'm not
GoFundMe.
actually sure.
Pretty sure that's how it works. And did you ever watch Shark Tank? No, maybe not.
No.
I have, and that's what they say on Shark Tank. We raised 20,000 on a goal of 10,000. That's what they say. Well, I mean, if you have, let's say you raise 140 from previous transactions, and then somebody wants to donate another 100 to get to 240. Where would that other money go? Who would get it?
Well, I don't know. I'm
You just
used to
send it.
things like Kickstarter, where you have a goal of 10,000, but then some of these, some Kickstarters, they have a goal of 10,000 and they get 1 million. I'm pretty
Exactly.
sure that they don't get to use the million.
All right. It doesn't matter. That's how this one works.
Okay, yeah.
So I think this file might be done. And I don't even know. I'm just going to click this run test. Let's see what happens. Maybe that one will pass. Running and send it. There it is. So if the 150 tokens get sent,
Yeah.
it worked.
Nice.
Oh, but I also need to. So add a transaction. I guess I need to update contract state dot status equals closed, maybe. I think it's what I'm supposed to do. Then update contract state. We'll just copy.
I would just move that line to the bottom of the file.
All right.
Yeah.
That's a good call.
Yep. Is it supposed to be a capital C?
Here?
No, the closed.
What did these already say? No, it does not look like it. Okay, I guess we'll run the test then. We don't have to go through that process of deploying. There it is.
Oh,
Now we
nice.
need, yeah. Now we need to do this other one on new block. So this is whenever a block gets mined, we need to, if block length greater than 7 or something, send all transactions back to donors, I guess. Yeah, something like that. Okay.
In my mind, you should count the block number from when the contract is deployed, and then 7 after that.
You definitely should. That sounds better. Obviously, it'd be tough to do things with time or something, which is what you really probably want to do.
Yeah.
This is just, yeah, that would have been better. Why don't you tell me that sooner? All right. This is how it is though for now, and
Yeah, no, that's a bonus to whoever's going to go through this. They can, at the end, switch up their contract so that it finds out the block that it was deployed, and then the logic is 7 after its deployed block.
no, I like that. So we're gonna have contract state dot transactions dot for each, maybe. What the heck is that? Maybe some sort of loop to go over all these transactions. A transaction, and it was the get the private key. So this is from the contract to tx dot from address, I think, and tx dot amount. That looks right.
I think so.
So yeah, if blockchain length, which comes in running the commands to deploy your contract and mine 7 blocks. So I think there's a note in here about something when this is actually run.
It says immediately after the block is mined.
Yeah, is that what it says?
Yeah.
So it should be greater than or equal to 7, I think. Okay. Is that it? That can't be it. We need to also, if blockchain, update, screw this. I'm going to copy this. Contract state, let's just do if blockchain length dot greater than 7. And contract
It's
state.
not already closed.
Not equal to closed. It's kind of sketchy condition there. Should work.
Yeah.
Good enough for me. So if it's not closed, update the contract state. Contract state dot status equals closed. And I'm gonna run the test. I might be missing something, but it looks pretty good. There it is.
Wow.
All right. Apparently my functions are working.
Yeah.
Now we need to kind of start over and deploy it and actually send it enough transactions. I think, like it says, the current state should be status closed and a description. Oh, I'm supposed to change the description. Your contract should have had at least 150 tokens sent to it. And it should have added a transaction sending all the tokens back to the creator, or to the creator, whatever. So we have to kind of do that. I'm just going to start over, initialize, deploy. I'm just going to mine. How many do I need? 150? So like 6 blocks so I can have tokens to send. Just flooding the market here. Blockchain.json. Oh, those. Wait, what? Where are my transactions? Oh, they're there. They're here. I just didn't scroll down. So now I should be able to go. We deployed it. Node add transaction from wallets. Private key to oh jeez. Copy, paste. It's like the slowest copying and pasting you'll ever see. Paste. Okay, so from somebody to the contract. Let's see it. That person doesn't have any money. Figures. From this person. No. There. Okay, that should work. Fresh transaction to the contract. So I think if I just do it again. Do you have 3? No, now you're out of money.
Well, that should be enough, shouldn't it?
Oh, that's only 2. That's only 100. It's supposed to be 150. That first one was one of these.
Well, now you've mined too many blocks, haven't you?
No, it says your blockchain should have at least 6 blocks. Oh, maybe I have. Because at some point it's gonna. Oh no! At some point it's gonna send the money back. Oh
yeah.
Crap! You're right.
Just delete the last JSON.
Whoops. Yeah, that could potentially work. A little hack, but node add transaction. Node add transaction. We're gonna go like this. Did it work? Did it happen? I didn't see any logs. There's 150, I think.
Yeah.
I wonder if I need to mine the block. I wouldn't think so. Maybe I mined too many blocks already, and you were right. Let me node run contract. Yeah. Might be in here. Contract wallets. I think I used the public address. I'll paste it in there. Say get state.js. Closed. Now, I blew it. All right, we're gonna start over yet again.
Yay.
Initialize.
Maybe don't mine 6 blocks, just mine 3.
I wasn't thinking. We have 0 blocks. Now we have 1 block, 2 blocks, 3 blocks. We do 4 so that we have enough coins on the blockchain. It should be. There's our first block.
You could also just manually edit one of the wallets to have 100 or 200.
No, you can't. There's a test that checks that your blockchain's valid. I could change the function that rewards me, I guess. It's node add transaction from private key. I really wish my hotkeys were working. To the contract and 50. Okay, you're out of money. We'll try you. That should be it. Transactions.
Hopefully, yeah.
There it is, the 150.
Wow.
Now if I run the test, is that it?
No, you don't have 6 blocks.
Uh-oh. Your contract should have had at least 100 sections and should have added a transaction sending all the contracts. I wonder. Oh boy, none of that looks good. Maybe I just need to mine it.
Yeah.
So how many
Before you reach the 6 blocks, be sure to edit the description.
That's true, huh? Thanks. Okay, so what have I got here? I don't even know. I'm not gonna worry about it. Let's do this. Node run contract address. I think use the public key. Update description.js. Smart contract to raise funds for my startup. Node, find one more block. Cross our fingers. You cannot update the state of a contract that is not open. What? Whoever created this is just evil.
They
seriously,
wanted you to go through all of this.
I gotta do it again. Unbelievable. Okay. I guess it's some good practice. So we deployed our contract. I'm gonna node mine block. Node
Imagine
run.
how much easier this would have been if your addresses were a reasonable length.
Mm-hmm. Or if my hotkeys were even working. My hotkeys are. I can't paste into the terminal. I don't know why. With Control V or whatever. I don't know. So we have my contract. So the first thing we're gonna do, run contract address, update description.js, smart contract to raise funds for my startup. I'm gonna just run the tests and see if, make sure it's passing before something crazy happens. The current state. Oh, well. Yeah, that's pretty rough there.
Now, let me tell you the problem, because someone's going to come along, they're going to forget the period at the end of that description, and they're going to mine all of their blocks, and they're going to fail that last test.
All part of it.
Yeah.
Okay, so
If you check the console, though, you can probably see whether it's failing because of the description or because the status property is closed.
yeah, you might be able to. So you got that. Contract address. Paste. 50. Money. Get address info. So I mean, I could be doing that, but I'm just copying.
Yeah.
Probably the same time to do both. So you have all the money, or I forgot to mine a block or something. No, I definitely mined blocks. Who has the money? What's going on here? We've got a blockchain. 50, 50, 50. Somebody's got money.
It's probably the
Get address info. Does that work?
I don't know.
Name of address. County properties undefined.
It's saying get wallet address is returning undefined.
All right, you want to make a note of that one too?
Yep.
Oh no, never mind. I just had a typo. It's a capital
Oh.
M.
Okay.
Okay, so here is the public address and the balance for me. Did I not do it right? Private key. We'll copy it. I swear I did this already. Paste. Boom. Boom. Should you have 100? Now he's out of money. Transactions. I don't see any node get address info. Don't see any $150 transactions yet, so, or whatever, coins. So let's do this one. Paste. There. Should be it. A little anticlimactic, but node get. I was gonna try and run the I'm gonna do it. Node run contract. Copy. Paste. Get state.js. The transactions are all still there. Close smart contract. Good thing I didn't have a period missing or something. Well, let's find out. Maybe there's a typo. Come on, fingers crossed. It's still failing. This should all be that. Those two should be working on smart contract to raise funds for my startup.
Go to the console.
Sure. Yeah, this is not going to be helpful. My expected
Okay.
0.
Did you mind the block?
Maybe not.
Yeah.
Maybe I need to do that. Let's try it. This one say?
Actual open, expected closed.
All right, we'll try it. Maybe I just needed to mine it. Come on.
Yes.
That it was.
Whew.
Wow.
Wow.
Well, we got another one. So, nice work.
Yeah.
All right. The next project is this peer-to-peer network. So let's just try and check it out. So when I click on it, it starts me down here.
Yeah, it's because it's a single page app, so
Yeah,
the scroll location is staying the same.
Okay, so yeah, it's pretty minor, but I guess what we're gonna try and do here is build a peer-to-peer network, sort of.
What gave that away?
That was the title right there. It's distributed. So we're gonna be working in this folder. We have some boilerplates. We don't need to change any of that. An old one folder right here represents a node on the network. The files in it will be cloned and used to run all the other nodes on the network. You only need to change the index.js file. So we're going to use WebSockets and WebSocket servers to create a WebSocket server in here, and it's going to listen for incoming connections, and it's going to connect to all the other nodes on the network. So once we think we have this file finished, what we're going to do is run this clone node thing to copy it, and then run a bunch of different nodes, I guess. And so we have to have at least 3 nodes. And we need to create a WebSocket server. And so basically all the servers are going to connect to each other. And we have these like known peers, which are kind of like entry points to the network. And then once one of the sockets connects to one of those entry points, it will handshake with the server, and the server will send it the list of all of its connected addresses. So, and then from there, it will connect to every other node on the network.
So we're basically simulating or creating a flood sub network protocol.
Sure. Yeah. I don't know, to be honest. I'm gonna go with it. Sure. So we're gonna have to have some server listening When it starts, it should attempt to open socket connection. So it should attempt to connect to known peers. When a socket connection, when a connection to server is established. Okay, so we're going to try and connect to these, and if we find a connection, we need to send it a string object that says this: type handshake data array. So it looks like we have the address of the server here. Data should be an array of addresses that your server is connected to, including the server's own address. So we want data connected addresses. That's what we need. My address connected addresses. Something like that. When a server receives the above message, it should attempt to open a socket connection. So when I connect to a server, I send it this. And when my server receives this, so something like server dot on handshake connect to all data array. You should keep track of all the addresses the server is connected to. You can use the that. When a socket disconnects, you should remove it. So I guess that would be possibly like socket dot on close, I think. Move from array, something like that. You should keep track of the servers you are attempting to make a connection to, so you not try to make more than one connection to the same server. Okay. And then after you connect, remove it. Yeah, there's some issue. I remember adding that. There was some issue that was causing an infinite loop of servers connecting to each other.
Yeah.
Server should never attempt to create a connection to its own address. You should clone your node one folder at least 2 times. All of your nodes should have the exact same code with the exception of the .env file. You should have at least 3 nodes running. Use those ports. All of your nodes should have an open socket connection to all other nodes. There's a bonus there. Hence, adding console logs can really help WebSocket servers. Okay, here, this looks promising. Copy. I can't even copy from there, can I? Yes, I can. Server port. So I'll make this server, and the port is going to be my port. And then server.on connection. So to create a server listening on the given port, I wonder, so that's listening already? Server.on connection. It's gonna go like this. The connection on the log. Connection received. That socket.on message runs when a socket sends a message to your server. Nest it within the connection function. Okay, yes. You want to make a note of this? I'm missing closing parentheses right here.
Yeah.
Thank you. So we have a string that comes in that's console log message received. And I'll just go plus data string. I think that'll be this. Pretty sure. So and how to work with sockets. So here's like your server, and then you kind of want a second thing, which is opening a socket connection to the server from the server.
Yeah, so you want to act as a server, a WebSocket server, and as a WebSocket client.
Pretty much. Let's run a test. I got one.
Nice.
Okay, when a node opens a socket connection. So the first thing we want to do is try to connect. And I know I need a connect function, so I need like this function connect address. That's what I'm going to do. And the first thing we want to do is up here anyway. We need to attempt to open a connection to all those addresses. So something like known peers dot each peer connect console log attempting to connect to peer address. Save it, and we'll just see if anything happens. So I have to go actually into this node 1 folder, and then I can run that. Okay. And something is running. We are attempting to connect, and it is still running. It is not stopping running. But successfully made a for each call loop. So if we want some catches here, if address not equal to my address, so we don't want to try and connect to own address, and we're not attempting to connect to it, and not attempting includes address. I think that should work. So we can actually test that. I'll leave that console log in there, and this first node has a port of 4001, I think. Yeah, that's my own address, so it will not attempt to connect to that. It should only attempt to connect to that one. Okay, so attempting to connect addresses dot push address. So we are now attempting to connect to an address.
Yeah. When I went through this. I remember I wanted to use sets just because I think it works quite well when you have elements that you don't want to repeat and that you want to easily remove. So that's just a
Did it work?
hint.
Did it work or not?
Yeah, no, it works. It's just you need to remember when you're passing it through the API to, I think sets have a toArray method, or else you just have to say array from and then pass the set in.
Yeah.
Yeah.
Okay. So when a socket connection to a server is established, it should send a message to that. So I think we want to move this handshake message and trying to connect, and then once we do connect, we want to send this. You go to these helper syntax, server, sockets. So I think we do, yeah, that looks right. So all in here, we're going to try to connect to this address. On, open, on, close, on, air. Runs when a connection to server has been established. So that sounds promising. So I should, in here, want to send this message. Socket.send. Socket.send data. I want it to be, just go. No, I can't go like that. Is it JSON.stringify, or is it something to string? I think stringify works here. Yeah, it's JSON.
Yeah, that's what I do whenever I'm working with WebSockets.
I think I'm missing another one of these. Maybe I'll just give myself a little more formatting there. And I don't know why I'm getting 4 spaces. That is no good. But I can handle it for now. Okay, so let's I'm gonna throw console log connection open. So you know what else? We need to do a attempting to connect to addresses dot splice or something, and then find address one. That won't work, will it?
No. I think you need to do the
Index
attempting to
of.
connect addresses dot find index.
Yeah, it's the index something. So can I do attempting to connect addresses dot index of?
Yeah.
I think that'll work.
We'll see how many off by one errors there are.
No. So, and then we want to go to connected addresses dot push, I think, address. So we have now connected. Connection open. And then socket dot on close. Socket dot on error. Probably just, I'll just throw some console log error connecting to, let's throw that in there. Attempting gotta remove it from this. And then on close, we should just console log connection to closed. Connected. To connected addresses. Move from there. This is going well, I think, although it may all crash and burn on me, but we'll see. So, get that.
I'm trying to think all of the things that fire the error event, that emit an error event for sockets, because what happens if you splice and index of returns -1? So right now you're treating it as if on error only happens when there hasn't, when on open hasn't happened.
No.
And I don't know what splice does if attempting to connect .index of returns -1, because it might start from the back of the array and then just remove some random last element.
Throw an error. I'm gonna bring this tab over. I think you're onto something. So if I splice a -1, 1, this turns into this. So it removed June for some reason, the last.
Yeah. So I think, yeah, I would take that attempting to connect address out and make sure that it's not -1.
Yeah, I like that. Address if index greater than or equal to 0. Index.
Yeah.
Like that, and probably feel like I wonder if I should do the same thing here. You'd think it would always be in here if it's closing. We're gonna leave it. We'll watch it crash.
Yeah.
So we start up, we try to connect to the known peers. None of them will be running right now. So nothing's gonna happen.
Yeah.
And then message received. So the message that we receive should be this message, handshake.
Yeah.
And then,
Well, do you want to? I think you also have to parse that message into
yeah.
JSON if you wanted to. But you want to just create a bunch of nodes and test it out.
See what happens.
Yeah, because they should try to connect to each other, shouldn't they?
They should send some messages around.
Yeah.
Okay, so there's some helper functions to run to clone it. I'm in the node 1 folder, so I actually have to back out here, and then I go node, clone node. I'm gonna do it twice, so we have 3. So now we have 3. I'm gonna come over here and split this up. And then now I gotta go into each folder. CD node 2, mark, CD node 3, and run the thing. We got problems.
Oh no.
Attempting to connect addresses. So you gotta go back. You can't just copy the code over to the different nodes, which is probably the way to go. But you can also use this node delete nodes, which will delete the things. And you go node clone CD
Okay.
node 2.
I would have tried running the first one before cloning them again, but
Oh,
yeah, you need
attempting.
it's syntax error.
What's the error? Cannot find name. Attempting to connect. Attempting to connect addresses. Attempting to connect addresses. Tempt. That's a typo in the boilerplate code. Attempting.
I think I'll add that.
That is a problem. Attempting. It's everywhere. Oh no. Attempting. Okay, we'll save it. Node run. Okay,
Awesome.
nice catch. We are attempting to connect to 4003. We got an error because
I have to let my cat in.
it's not running. All right. node index. Oh, it did. It connected. Attempting to connect to. So this one tried to connect to both. This is 4002. Error connecting to 4003. That one's not running. Connection to 4003. Open. Connection open. Connection to open. Okay. So we had a connection opened to 4001, and then we received a message on 4001. We received a message here, and it's got both addresses. And so I guess const data equals JSON.parse data.
Not quite.
Whoops. Data 2.
No, not quite.
Data string. Oh, there we go. Okay. I don't like this anyway because the field is data. We'll go message. And then message dot. Oh, what the heck was that? Do it again. I have a typo. Message dot data dot for each address connect.
Yeah. I want to see how many times you'll do this. Okay.
Like, is that all I need? That might be enough. All right, well, let's try it. So they should connect to each other. I'm gonna reclose this one. Delete my nodes. Clone them again. Node index will run this one, so it's running.
Why does it print closed there at the end?
Connection closed. Connection closed.
Okay.
So there it is. Your error connecting. So first it goes to error, and then it goes to closed for some reason.
Well, I suppose that makes sense because it connects. Or does it connect?
Well, it attempts to connect, right? It doesn't actually connect until it gets a response, I presume, or something.
Yeah, I don't know why it would close if it hasn't opened.
No, I don't know.
Oh well.
Node 2, node index. So now we are in a loop. Oh no.
That's fun.
Stop. Somebody help. Trash it. Trash it. Okay, we're alive.
That's quite fun.
So, if address not equal my address and not attempting to connect addresses, that includes address. Socket.onClose on error. Let me see what it says over here. You should add. What the heck happened? I can't even see my terminals to find out. So I had a server listening.
Yep.
I started up the first one.
Yep.
And then I started up the first one, tried to connect, but it didn't make any connections because there's nothing else to connect to. The second one opened and connected to the first one and sent the first one this message, its own address.
Yep.
Just its own address. And so then the first one tried to connect to the second one. Which it assumingly.
Do you want to not do the connect if it's already connected? So
not, yes.
You need another, yeah.
Yes, I do. That is the problem. Perfect. That's teamwork right there.
Yeah. You don't think there's anything wrong with that?
If connected, okay. I'm doing this with my eyes closed. Okay. If address not equal to my address, and if not connected, it's okay. All right. Let's try it again. Okay, we've got several nodes. And run that one. Okay, that looks good. CD node 2. Index.
Okay.
Okay, I think that's good. So this one got a message with the 2 addresses, and then it attempted to make a connection there, and it opened one.
Nice.
Let's see what happens here. CD node 3.
Okay.
No, that'll break. We've got a whole bunch running. 4
Nice.
nodes running, all connected to each other, and I think that should pass the test.
Well, no infinite loops is a good sign.
Crossing my fingers. I see a lot of X's.
No.
Socket.on message. Do I need to do more here? On close, on error, send data. That really looks. Go ahead.
Well, I'm just thinking, so the server, it's only connecting when it receives a message. Does the so you have on open, you're sending something. Don't you want to send from the server the connected addresses, not from the client?
This kind of is, the whole thing is the server. You can call it a client, and yeah, that makes sense for typical WebSocket stuff.
Well, that it the so when you say new WebSocket, that's a WebSocket client.
Yeah.
When you say new WebSocket server, that's a WebSocket server. So I'm thinking when the server receives a connection, the server should send, here are all my connected addresses.
You might be right. Didn't read any of this hardly. No, I did read through it pretty good. Sorry. So when you connect to a server, you should send it a message with these. But the server doesn't need to, because
what you're basically doing right now is, if you start up node 5, then it's not connected to anything, but it's whoever first it makes a handshake with, it's saying, here are my connected addresses, as opposed to connecting and the server saying, here's everything I'm connected to.
So node 5 would send it. It would start up. It would connect to this first one and send it its own address. And the first one would receive it and then attempt to connect back to it. And then when the first one connects back to 5, it would then send all the connected addresses, where 5 would then attempt to connect to 2, 3, and 4. Maybe that's not the right way to go, but
What is there anything in the console that's giving a reason for the failures?
doubtful. This is not.
No. So that says it's crashing. As in, it's throwing.
The tests pretty much just try to make connections to all the different things and see what the handshakes come back is, or something like that.
It's not reaching the assertions, which is why it's just an empty object.
Do you think I mean, it seemed like it was working. They were all connected to each other. So it seemed like that they should have passed and that it was working as it should have been, right? Or no? Maybe I'm missing something.
We'll start node 4 up again.
Let me close all
Or
these.
everything.
Oh, there we go. So node 1.
Not quite.
Turn over. CD node 1 node index. CD node 2 node index. So node 2 started, attempted to connect to 1 and 3, error on 3, and 1 worked.
Yep. And then the message received is I am connected to 1 and 2. Yeah, okay, so it's my address and connected addresses.
Yeah.
Yeah.
So that should be right.
Yeah. I think that makes sense.
CD node 3. Let's see what this one said. It gets a little busy here.
Yeah.
Attempting to connect to 1 opened, and then it sent me all these.
Yeah. Attempting to connect to 2.
And the first one received these 2, which seems right.
Yeah.
Attempting to connect to 2, and it did, opened, and then it received, so 2 sent it back this. And then it stopped because it was already connected to all those.
Yeah.
Message type handshake data. I see something. I see something.
I know.
I see something. Yeah. Okay, so I'm gonna this time going to copy code. Okay, I think that looked right. The tests.
It's pity nothing would show up in the console though. Nice.
We got it. If I run the test
Cool.
again, there they go.
Wow. So how long did we spend on a typo?
About the average time you usually spend on a typo.
Yeah. Awesome. That's 3 down. So moving on to the 4th project, which is building a Web3 client-side package for your DApp. And in this project, we're going to be building a client-side package that's in the form of a class that can be used to interact with a Web3 provider, which would basically be your network for a blockchain. We can see the files we have here. The class is in this index.js file that we need to build out. We can see an example of a provider here, which is basically just a REST API consisting of some routes that you would interact with in RPC calls. And so we should first cd into the build a Web3 client-side package tree. And we have the boilerplate in the index.js file. And we can see an example of the way that this API that we're building out is going to be used in this example client, where we are importing the class. And we can see some methods on this API, such as set client address, init smart contract. And we can see that basically the API just uses this to interact with the smart contracts that we'll be building out, where we can call the methods that might exist with the smart contract. And there's an example IDL that we pass into init smart contract that we can find here. And this is very basic IDL, which is basically a schema of your smart contract. It tells you in these instructions, it's basically the methods of the smart contract. We have a set click method and a get contract account method. The args expected for the set click method is one argument that is of type string, and there are no arguments to the get contract account method. The user stories that we will be completing, let's just go for it. So we know that we need a method that is set client address. And that takes in an address and doesn't return anything. And what this method does is it sets the class address property to the given address. So that's this dot address to the given address, which means that we need to construct our class with some address that I'll set for null. Now, okay, we'll call that one down. The next method is call, and it accepts an RPC call object, and it returns a promise. So we know that this is asynchronous. And what this does is makes a post to the call smart contract route on the href of the provider property. So this class will have a provider property that will be equal to something. And we will want to make a fetch to this route, which what we can do is provider href, and it is to the call smart contract route. And then we want this to be post method, which means we will have a body, and the body of the post should be the RPC call object literal and the address property of the Web3 class. So we need a body here, and let's just create a body that is the RPC call and the address of the class.
I remember when going through this that I struggled with the URL there. That when you make that call smart contract, it doesn't need the /. That between
Quite
that.
right.
Yeah.
So we do have a link down here to the URL API of its basic JavaScript API that also exists in Node. And if you play around with it a bit, you'll kind of figure out that calling href, it always appends to the end of the string the /. I suppose the smarter thing to do here would be to, I know in Node you would use the path API to the path module and the join method, and you would join these two paths together. Top of my head, I can't think of how to do that with the URL API, but I'm sure there is a way. So now we need to, the call should return the result property of the response or throw an error if the response contains an error property. So what we need to do is get out the response, which is on.parse res, and if response.error we need to throw, in this case we'll just throw a new error that is that error. Otherwise, we want to return response.result. So that should be that method done. And now we need an init smart contract method. So we can see this also.
Would there be a way to, sorry to interrupt, would there be a way to test this to make sure it's working other than just like running the tests?
That's a good question. So it would be a bit difficult. You would need to get the provider up and running. So what you can do is create a new terminal. Just you don't need to create a new terminal. You can start the provider by saying node provider.js. Leave. And we can see here what that does is it starts the provider, it deploys the smart contract with just a test smart contract that is located in this package file. And then it starts listening on port 301. So I suppose we would need to set the provider here. And we could manually do that with new URL HTTP localhost 301. So from then we could actually just write some tests ourselves. So if we wanted to, let's just do something simple. So we could set the client address here, and we could just make a Tom. And then we could console.log the web3 dot address. I think if we did that, we can open ourselves a new terminal here. And we could run this in Node and it should work. So, except it is a module, but we'll see what happens. Node.
There it is.
So we have tested that creating the class works. It starts with an address of null, and the provider is this URL object. And then we change the client address from null to Tom, and we can see we print it out there. If we wanted to do a test on the call, we could down here say web3.call, and we would need to pass in an RPC call. What that would require is, well, we could look at it from the provider's perspective. The call method in this case makes a post to call smart contract. So here's call smart contract. It gets from the body an ID method, args, and address. So if we wanted to, we could just add in an ID 0. Args would let's leave it as an empty array. Method will probably just get this wrong and we can say test. What else do we need? Address. So the address would be the web3 dot address. You can pretend that that works. And this is an async method, so let's just get the response out of that. And console.log the response. And run our script again. And we get an error, which is very fun. Where is this error? In JSON.parse. So actually, while we're debugging, we can console.log the response here. And we'll check why that is happening. So this is the response. It looks like it's just the old average HTTP response. And so why is JSON.parse not working? Probably because we need to use the await res.json method. And let's not console.log that. Okay, so we get a response from the server here, which is smart contract with ID undefined, not found. Why is it saying ID undefined, not found? That is a very good question, because we have defined it as 0. But clearly that just doesn't exist, and we can see here. Also in the provider, it's logging out those errors. So let's clear that for now, and we will come back to it. That is a bit more involved than I would hope it to be. You can see it basically, if you get an idea of what's going on in the background, you need a provider running, and then you can just run the script using Node, and it all works. And fetch works in the fetch API works in Node version, I think it's 17 and above. So 18 is officially released. So that is what the Docker image is running on.
I feel like that would help. It would have helped me when I was playing with this, is kind of a way to test it more and see if it's working or not, rather than just kind of writing the code and hoping.
No, that is a good point. It's probably something we can add on to this in future PRs to make it more user-friendly and just a bit clearer. Obviously, I think once you've gone through the practice projects and you've learned a bit of content and you understand RPC calls better, as well as having built out your own provider, it makes a lot of sense what is happening here, where the fetches are going and what's being returned. But until then, we can definitely try and make it better. So this Init smart contract, what we need to do here is we need to take in the IDL, which is your smart contract signature. And we need to basically turn that into callable methods. So we can start by, we know we want to return the smart contract methods. And that means we want an object. And we will want to, here's an example. If we have an IDL with these instructions where we have these different methods defined by the handles, get favorite number and set favorite number, you can see that after we initialize the smart contract, it returns a smart contract object that has these properties, the set favorite number method and, sorry, the get favorite number method and the set favorite number method. So what we will want to do is, for each instruction of the IDL instructions, we'll loop over that and add the handle to the smart contract. So we want to put in the instruction.handle. We need to set that equal to a function. because that's what the instructions are. They're just functions. And in some of the cases, the functions will be asynchronous. They don't have to be, but they can be. So we just add the async method there, and we know that there are some args that this will accept, but we don't know how many. So we've defined it as a function. Now, what we need to do is the callable method should return a promise. Okay, so that's set here an async, and it resolves the result of the call method. So somewhere in here, we are calling this dot call, and we are returning it. So this dot call set, we are awaiting that because call is asynchronous promise. And from here, we need to construct the RPC call. So just as we did down here when we passed in the RPC call to the call method, we are wanting to construct this out of, where am I? Yep. We want an RPC call. We need an ID, which actually needs to be inside the for loop. And even more so, we need it to be inside the function. And we get from the instruction, it's actually from the IDL itself. It has a property ID. See that in the example. We need to pass in the ID of the smart contract so that the server provider, or in our case, more likely a validator, will be running the actual code of the smart contract, needs to be able to find the smart contract on the blockchain. So we pass in the ID. And what else did we need? We needed args and a method. So the method we know is the instruction handle. And the args is the args that are passed into the parameter of the function. And did we need anything else? So the address is done by the call property itself. We actually didn't even need to include that. It's overridden anyway. When we wrote this out, the body added the address for us. So it's just the RPC call here, and we can pass the RPC call into this. Now, what we need to do at the end of an init smart contract is return this object that we have just created. Okay. Are you happy with that, Tom?
I think so.
Okay. Well, we are moving on to create this get balance method.
If you ran the tests, would it pass those, or is there?
We can try and run the tests, definitely. Always a good idea. Run the tests as often as you can, and hope things don't break. So we run the tests, and we are failing absolutely everything. There are a lot of tests here, so actually, if you're wanting more information, you can probably read the test text yourself. We can look at why it's failing, and it seems that something is erroring out in our code. I think one of our issues that I definitely know of is when we are creating our Web3 class.
Yeah.
We need to actually pass in, and I'm pretty sure I had it written here somewhere.
It is. Remember it. It's an initializer or something.
Yes.
And you get the address from that, the provider address from that. Node.
I never know where it is.
I wonder if it's
Yes.
in the costing.
So in here, we need the provider address, and we just replace this hard coding that we did for our testing provider. And I wonder if changing that will allow us to pass any of these tests.
Is it provider.href or URL or something? Or is it just provider?
Well, the constructor just accepts a string.
Okay.
And we turn that into our URL ourselves.
Okay.
And we're still failing all of those. So I think one of the better things we can do is finish out the API here.
All right.
Just so we don't get any crashes. And we will be defining a transfer method that takes in an object, and let's just say from to amount. So this is all to transfer from one address to another address a certain amount. And if we do that, see what running the tests does. Nothing. We can look into what is actually happening by reading the server output. So Web3 is not defined. Which means we are not exporting this well. We need to make sure, let's just comment about our tests for now. Okay, there we go. So our tests were messing up the output there. I'm not exactly sure why, but we will leave it like that. So we are actually passing first 5 here. We're exporting our class. So your Web3 class should have a provider property that is an instance of URL constructed from the initializer argument. That's what we've just done here in the constructor. And we have the set client address defined correctly. There is an asynchronous method with the handle call. We have done that. And call makes a post to this route. So what we are not doing is post call smart contract should have a body including the JSON stringified version of the RPC object literal. So we are not stringifying our body. It's always something to remember. Okay. And let's keep going. So we need a content type header set to application JSON. So that would be in the headers. And we need content type. I'll never remember if this actually needs to be capitalized in a certain way, so we'll just try it out. And we are sending through JSON.
It looks like it's capitalized in the text and instructions there.
So if you read your instructions correctly, then you will probably have a better time passing the test. Thank you, Tom. So the request should have a body including the JSON stringified version of address. We are doing that. Yes, here's address. The call method should return a promise. Yes, we are doing that. If the response contains error, throw. Yes, we are passing that. Excellent. We're passing all of these. And then down here, we are failing one of the internal tests where it's actually testing out the API. So if we go to 17 in the console, we can probably see why. And these used to be in numerical order, but for some reason they are no longer. And it seems that it's just crashing there. So let's run the tests and see if we're passing any more. Yes, we are. Almost there. And now we need to actually define out the get balance API. So we need to make a post. This is more of the same that we did in the call. So I'm actually just going to copy paste this. So we are, no, this is fine. So instead of a fetch to call smart contract, we are making a fetch to get balance. And the get balance request should have a body including the stringified version of address. So there's no RPC call here. There is just address. And we can see back in the function definition that address is optional. So we need to fall back to, well, if the argument isn't passed in here, then we need to fall back to the class's address. And we also need content type here. Excellent, we've done that. Get balance method should return a promise that resolves with the result. I think we are doing that. Resolves with the result, yes. And if it contains an error, throw that error. We are doing that. Okay, let's see if we're passing those tests. Okay. And we are. So now we need to just do transfer. And I think that is, again, more of the same. Except now instead of address, we need the from to an amount in the body, and we need to JSON stringify this. So if we change body to just from to an amount, we didn't need to destructure it here, but that's fine, we'll leave it. And instead of get balance, we are changing this to type. Let's run this test. And I wonder if that's it. No. What are we failing? If the response body contains an error property, transfer throws an error with the value of the error property. Are we not doing that?
Looks like it.
Well, then let's go to the console and see what it is. Expected missing required fields to equal missing required fields from null.
So that's, you're not destructuring correctly or something there in that body, I think. Body equals from to one. Oh, that looks right.
So in this case, we're saying from is undefined, but it expected from to be null. It expected from to be null. So actually, I wonder, what we want from to be is our address. So you know what, we should probably actually read the user stories.
I wonder if it says the body should be JSON.stringify body. Okay, you are doing that.
I suspect we need to actually say from, and this needs to be either from or this dot address. And that,
something's just wrong there, but yeah, that might work.
Yeah, we might need to make that actually clear in the tests and things. There we go. Okay. So we passed all of those. That was quite involved, but got there in the end. And
nice one.
Yeah. Okay, on to the final integrated project. And this one is build a smart contract in Rust. So for this project, we need to create and deploy a smart contract using Rust that keeps track of how many users have clicked a button. Very fun. And our boilerplate starts us with a Rust library consisting of unit tests and integration tests that we are expected to pass. So let's get that up here. Nice, so we can see where we need to edit our code, and these are the unit tests. The integration tests are in the tests directory. We can see those here if we ever need to actually look at those. So the boilerplate already contains the necessary crates to complete the user stories, but we need to import them into the code. And you will be required to define structs and functions matching those used in the tests. And we should only need to work in this lib.rs file. So actually, let's just cd into that directory, cd into build a, what are we, smart Rust. And we might as well just run cargo test lib to get this all going. That seems to be working well. And here are the user stories. Not too many. Some useful resources about WASM and Rust in general. And some tips. Okay. So let's get started. Our smart contract uses WASMPack to compile the Rust code to JavaScript for Node.js. We already have WASMPack installed, so that is fine, and we'll need to build our smart contract later using it. The smart contract exports an initialize function that returns this funny result. So we will need to export using the public keyword to make the function public, and it is a function, and we want to initialize it. And this function takes no arguments, and it returns this funny result.
Public function initialize with an S.
Okay, so we are returning that result, and what we can do for now is just say, okay, something. And I think, and you see here in the user story, it's this function returns a context wrapped in a JS value, whatever that means. This will probably help us wrap a value in a JS value using the from Serde implementation on JS value. But for now, I will just continue with the API and build out all the functions. So we also need to export a setClick method that accepts a JS value with the context type. Okay, so we need some sort of context type in there, but it's a JS value, it's not context, because it is coming from the JavaScript interface. And we are returning again the result. And what does this? So this function also accepts a string as the second argument. So we need to remember that. And which is the address of the user who clicked the button. So this one. And strings across Rust and JavaScript are relatively similar in that they're just strings. So we need, and I keep forgetting the FN keyword. Sounds a bit like I swore there. Yeah. Get contract account, it returns, it accepts a JS value with context type, so we can just context JS value and return anything. Okay. And this function returns an account wrapped in a JS value. Again, something that we may not know what means. So let's just add some to this. I enjoy doing that because we can run the tests probably from here.
What is this? This is just like a little Rust filler function that stops it from crashing or something?
Pretty much exactly that, yeah. So normally if you have a linter going with this as well, then it prevents the linter from saying, hey, you have unused stuff, and hey, you know, you say you're returning this, but you're not actually returning anything. So I find the to-do macro quite useful. But I remember that I actually need to import wasm-bind-gen, and we can use the prelude to get all of that fun stuff that we've used to add JS value and JS error. And yeah, let's run the test with this and just see if we pass any of the integration tests. But it looks like we are erroring out because of this. So when in doubt, to do.
I guess so.
Okay, so we are still not compiling because we need to actually define the account and context structs, which we have definitions for over here. So your library should export a struct named account. So let's just do that here. So struct account, and it has the following fields: total clicks, and that is a U64, as well as clickers, which is a vector of strings. And these strings will be the addresses of the clickers. Other than that, we need a struct named context, and that has a base account field, which is an account. Easy. And I think we need to make these public.
Vector, that's just an array or what?
So vector, it's a list, but it's pretty much an array, but more specifically, it's dynamically allocated, so you don't have to know the size of it beforehand.
Sounds good.
Okay, let's see if that makes the compiler happy enough. No, it does not. Why? Okay, so we need to do some more imports. In order for us to, crossover between the JavaScript and the Rust, or in this case, WASM interface, we actually need to serialize and deserialize the structures that we have. So we are going to import, deserialize, and serialize. And then from there, we need to annotate our functions such that we derive the traits for them. So we can use the attribute and derive serialize and deserialize for both of these. Okay, I wonder if that is enough. One day we will pass these tests. Okay, it looks like I actually need to spell correctly. Okay, so we are passing something, so that's useful to know. We have here some unused variables, and we are passing all 7 unit tests. Excellent. So let's move on to just do the integration tests. And that is WASMPack test Firefox headless. And you can run this in the browser, but it just outputs the exact same information that goes in the terminal here, so you might as well run it headless. And while that's going, we can see what else we need to do here. So at some point, we need to deploy the package using node deploy.js, so using the script. And we need to pass in the path to our package directory. And we should run node smart contract, passing in a contract ID, set click, and clicker name to add at least 3 clickers to the contract. Okay, we'll get to that later. Right now, it looks like we just have a bunch of WASM errors, probably because we are not annotating our functions that we're exporting as something for WASM to export. And maybe now we can actually get somewhere with these tests. Although we're technically still not returning anything, so WASM will complain. We can pull some more of these user stories. So this function returns a context wrapped in a JS value. So we need to create a context. Here is our context. So what we can do is just say let context equal context, and this has a base account, which value is account, and we need to start this with some sane numbers, I would assume. So we can do total clicks 0. No one has clicked initially. or when we initialize the contract, no one will have clicked. And for clickers, we will do an empty vector. That looks about right, except we now need to wrap that in a JS value. So we go back down here to the tips, we can see JS value has the from Surday implementation, and we can pass in a context. This is our context. And we want a result out of this, so we just need to say okay. Now, I don't have a linter for this, but I remember that from Surday expects a reference to the context, so we just need to little ampersand there.
Is that like a return then? It says okay. Is that
no,
it's returned?
So in Rust, we have implicit and explicit returns. And basically, if you leave out the semicolon, then it's an implicit return. This is standard. Basically, if there's no ambiguation as to where you're returning in this case, your functions, then you implicitly return. But if there is ambiguation, maybe you have some other if something, then it's better to explicitly say, hey, I could actually return from location. But okay, you're just wrapping something into a result. So wow. It's just a type here. We're saying that our type returns, and in this case, we're returning okay. If for some reason this initialize had some other logic and things weren't going as we expected, so in this case, then we could, instead of wrapping it in okay, we would wrap it in error. And we might want to do this, but in this case, because the function is so simple, there's not actually anything going on in here that wouldn't fail during compile time. There's no reason to have an error variant of the result. So let's move on to something slightly more complex, the setClick function. What are we doing with this? We are well, I suppose we need to find out by fulfilling the user stories in the integration tests. There we go. So if I go, we know we want to return the context. So let's just do the same thing as above. Let's copy that over. And we're not doing anything here, but at least this way it will compile. And in here, we need to return the account. You can see that the getContractAccount function, it returns an account wrapped in the JS value. Now the account is inside the context, so we actually need to access the base account field, and we can say let account, or in this case, let account equal to, we'd actually first need to get the context out. So I think we define context and say that this is of type context. And then we can use context dot into Surday. So into Surday is derived, implemented for context on a JS value, because we have explicitly derived it as part of the, I always forget if it's serialization or deserialization when you're moving this way. But anyway, and we are just using this operator to propagate the error out into a result if into Surday fails to derive it. To deserialize it. And then we need the account. So let account equal to context.base account, and we want to wrap that JS value from Saturday and pass a reference to the account. Okay, let's see if that allows the tests to run. No. And it's because from Saturday returns a result. So we need to unwrap that, and we can just so unwrapping all of these from Saturday calls. That's not how you unwrap. We can see if that allows the tests to run. No, because we have something that requires sized context. Serialize is not implemented for JS value. We are not trying to... Where are we? Over here. It is an interesting error. I think one of the things we need to do is, in order to get the account out, we are actually just taking a reference. And that might be all we need here. No, that wasn't it. Okay, where's the error? Line 30. Okay. Okay, so we've said this, no, so we need to let context equal to context. So that's what it wanted. Maybe, okay, so it's running tests. We passed 4, nice. We passed another 8. And then we failed some. So let's look at this. It's a lot of output here. But we can see that other than the warnings, we passed the 4 tests result to do with the initialize function. So the initialize integration tests, we're passing those. The set click, we are passing all of those, which is surprising. Oh no, we are failing this one. So it needs to push clicker and increment total clicks. So what we need to do is we need the account out of this. Account equal to, we want to mutate this because we need to increment the clickers context dot, we want base account. And then we need the account dot total clicks equals 1. That's plus equals 1. And we need to push account dot clickers push the address. So that should be all we need there. And now let's see if we pass any more tests with that. We can't borrow this as mutable because we didn't declare it as mutable. That's not where we did that. There it is. Shouldn't need that. Okay. Some more tests passing, initialize, passed all of those tests. Set click, we increment it, and we push it. Okay, so what are we fading? Nothing. Is that all we needed? Well, let's find out by running the test here. Okay, so we passed the unit tests there, passed initialize integration tests, set click integration tests, get contract account integration tests, but we have not yet deployed our smart contract. So let's do that by running node deploy.js. and the path to our package directory. Okay, so we need a package directory. How do we do that? We need to build it first. So we need WASM-pack. And do we have any more information about that? Build your smart contract with Node.js as the target. So we need to WASM-pack build. We need to pass in Node.js as the target. And click return. This doesn't crash. Okay, something's happened. It says that your WASM package is ready to publish at this location. So if we just double check, yes, the package is there. What we then need to do is just run that node deploy JS, and the path to the package is just package.
It's just package, yeah, I think.
Okay, we hit that and we get a bunch of errors. Maybe we need to
point it to the file.
We can try pointing it to the file, yes.
Oh,
a
that would be.
smart contract in Rust.js. Okay, so that's done something. Let's.
Wouldn't the WASM file be the contract? Or
So
no?
the fun thing about building the package like this using WASM-pack is that because we are interfacing with the JavaScript API, you can see with the JS value here, we need more information than just the WASM. We need to do a whole bunch of memory allocation and stuff. And that's done in JavaScript so that when we import the package, we can import it as JavaScript, and the JavaScript code then uses whatever WASM WebAssembly module in order to import the instance here and then re-export it. You can do this manually, but as you can see, there's actually quite a lot of stuff that you still need.
No.
And that's only because we're interfacing with the JavaScript API. If we weren't, then we could just run and use the .wasm as your yield average bytecode. So we've deployed that. If we run the test, we pass that, it's deployed. And you should add at least 3 different clickers to your contract states. So this, we need to run this command to add at least 3 clickers to the contract. So let's do that. Node smart contract.js, the contract ID. We can see here that the smart contract deployed with ID 0. So let's add 0 there. And we want to set clicks. So we pass in the name of the function, which is setClick, and the clicker name. Let's add Tom. And I think what we can do is we can view our blockchain in node data blockchain. So we have here clickers Tom, nice. We can add another clicker. Let's add myself. That's that done, that's mined another block, and the clickers are now total clicks 2 and clickers Tom. And then let's add Ahmad. Another block. Okay. So that should be it. Yes, excellent.
Woot.